Let's start. It's the slot after lunch. Okay, so I want to talk about what we mean. We had actually a very interesting example, which I'm going to come back to, all the relationships there. About 90 seconds ago, a bell went. That bell has meaning, okay? It's a bunch, all it is the bell is a sound. That is it. It is that we can understand the physics of it, but it has a very particular meaning. And that meaning is utterly bound up with context. Everybody immediately wakes up, oh, context, he's going to talk about bounded context. Yeah, maybe I will. Maybe I'll talk about a lot of things, and we'll converge on meaning. This is the polite version. The less polite version is, honestly, what are you talking about? What do you mean? So there's this question, what do we mean by software systems and stuff? And I love this bit. Maya Lehman wrote a wonderful paper from 1980, Programs, Life Cycles, and Laws of Software Evolution. There's a lot of good thinking in here, but I love this bit, this little paragraph. Every now and then you can find just a sentence or a paragraph that somebody clearly had fun writing. Any program is a model of a model within a theory of a model of an abstraction of some portion of the world of some universe of discourse. It's just like, I love this. It's just like, okay, somebody just snuck that one in there. It's an otherwise relatively dry but very informative paper. Now, we also mess about with this stuff. It tells us there's an awful lot of process here. How are we going to get the answers that we need? But there's this other thing called abstraction. And abstraction is one of these words we throw around an awful lot. I run a lot of workshops. And one of the things I ask people, and it depends on the nature of the workshop, sometimes people will put up things that say, oh, abstraction, high level of abstraction, and this kind of stuff. And I often ask people, well, what do you mean by abstraction? What does the word abstraction mean, or abstract, or the verb to abstract? What does that mean? And then kind of people look at each other and they come up with all kinds of definitions. Very rarely are they right. There's normally value judgment already embedded. People say, oh, abstraction is when you omit irrelevant detail. No, it isn't. Abstraction is when you omit detail. If it's good abstraction, it omits the irrelevant stuff. If it's not good, notice that there's a difference between the value judgment there, really very subtle. Abstraction is neither a good thing nor a bad thing. It is merely a thing. It is the removal of stuff. Yeah, Latin, abstrahere, draw off water. That's literally what it means. Abstract art removes reality. Abstract classes remove implementation. This is what abstract means. And we have a real problem with language, because a lot of people wander around, and I get this, I say, oh, yeah, we're really high level, we're close to the customer, this is it, we work at a high level of abstraction. Really? That's a very strange way of looking at it. Talk to a customer, talk to people who don't do programming. What they regard as programming, they think of as highly abstract. When we talk about low level of abstraction, what are we talking about? We're talking about, oh, you're close to the machine. When they talk about the machine, they think it's abstract. In other words, we've got the world upside down. If you really do believe in domain-driven design, you should be working at the lowest level of abstraction possible. That is the customer's world. Yeah? It's such a programmer-centric thing to say, yeah, we're working at a high level of abstraction with the customer's language and concepts. That's not high. That's really, really low. You're trying to get close to them. It is not, we're using the wrong orientation. We're using a vertical orientation. It's actually distance. We are far, we are near. It's nothing to do with up and down, okay? Language is very tricky, and it deceives us. But this also leads to a reputation where we end up with just being a bit vague. Dijkstra made it very clear, the purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. Now, I've just used the word semantic there, and this is one of those things. Eventually, you will end up in a debate. It will either be over beer, or it will be over politics, or it will be over code. And somebody will say, oh, that's just semantics. And it's just like, it's like you just dismissed it. Oh, it's just semantics. What is semantics? Semantics is meaning. Oh, it's just meaning. It's like, well, what else are we working with? Did you have something else in mind? What is it that we're doing here? What is this stuff, software? There's a lot of different ways of looking at it, but one of the things you're trying to do in constructing it is you're creating a system of meaning. And you may use metaphor, you may use all kinds of things, but you are creating a system of meaning. The more coherent that system of meaning is, the easier it is to navigate, and the less surprised you will be. Also, the problem is, though, we build these things over time. So we have our early understanding mixed in with our recent understanding. So we have this stuff called code. And then when we start looking at code, people have a very different set of takeaways when they reason about code, or when they talk about code. You can find this when you ask people about the programming languages they use. And for many developers, when you say code, they immediately think of the thing that appears immediately in their IDE and is their favorite programming language, or is the first programming language they will put down on their CV. And they'll say Java, they'll say C#, they'll say Ruby, they'll say whatever. Yeah, that is code. But so's that. Oh, and so's that. And the config files, and these are all code. These are all code. You know, oh, we solved the problem by putting it all in XML. It's not a coding problem. Oh yeah? Have you seen XML? Honestly? Really? Oh yeah, it's fine. XML is human readable. What kind of humans were people talking about when they said that stuff? But what we do have across all of these codified forms is what you're doing is that the system of meaning, the development that you've got, and particularly where you're dealing with a team, particularly where you're dealing with multiple developers over time who may never meet each other, is what you're dealing is with codified knowledge. It's a nice play on the word code, but it's another way of thinking about it. Our code base is codified knowledge. This is what we know, or at least what we believe. Perhaps it should be called codified belief. But codified knowledge, this is what we believe, and this is our system of meaning. Now, when you look at it like that, that's I've mentioned this to a couple of teams, and they've got a little bit depressed because they've said, oh, you mean that's our knowledge? Wow, we're a mess. This is what we know? Well, we're all over the place. We believe half a dozen contradictory things simultaneously. Yeah? Here's what I believe today, what I believed last week, what I believed last year, and what some other guy who I've never met believed 10 years ago. And it's all kind of smashed together at the same time. It's like having a conversation with a flat earther. So, but when you start looking at it like this, you suddenly realize, oh, okay, it's a knowledge base. That's what the code base is. It's effectively an understanding of here is what we believe we're supposed to be building, and here is how we believe we should be building it. It mixes these worlds together. It also means that the very process of development gives us, we already know what it should look like. And this is kind of an interesting one. People often say, well, development process, we're using Kanban, we're using Scrum, whatever. We're being agile, we're being fragile, what are we doing? And actually, that's asking the wrong question. If the goal of software development is to codify knowledge in an executable format, then what we need is knowledge acquisition and retention. But what we need is knowledge acquisition. Please use this term when talking to others, particularly who have paying power, because it sounds good. Okay? So tell us about your development process. We're using to establish a model of a model within a world of discourse. We are using a process of knowledge acquisition. Whew, okay, you've got the contract. Sounds good. Those guys really know what they're doing. Yeah, the rest of us just say, oh, it's learning. It's a nice short word, but knowledge acquisition sounds that little bit better. Okay, there's a little bit of extra stuff in there, a little bit of Latin as well. Now, the thing is, how do we get learning around? This starts telling us it's an act of communication. So software development ultimately involves an act of communication. It's one of the many ways I can transport my understanding to you is communication. Now, this is in the code, it's in the team, it's in the air. It also means that what you are building in a code base, what you are doing is social negotiation. The very act of creating a code base is social negotiation. Even negotiating with yourself over time. If you are just on a personal project, you will find you have to argue with yourself. There was past you, and there's current you, and there's future you, who you have some really high hopes for, but those will be disappointed. You are negotiating the language that you're choosing, the boundaries that you're choosing, the choice to partition or coalesce. And this also has an interesting consequence. It also means that a number of these decisions of structure and meaning create a model of participation. They tell us how we're going to work together, how we're going to work over time. The more formal, obviously this sounds a little bit fluffy. If you'd like something more concrete, just call it software architecture, but that's what it is. It's a model of participation. That's one of the many things that software architecture can be considered as. Now, all this is well and good, and let's just sort of leap over and say, well, software architecture. I'm always interested in metaphors, because a metaphor comes with a set of meaning. People are like, oh yeah, okay, architecture. And people have various debates about, oh, do we do architecture? Is it like building architecture? We have the same with engineering and all the rest of it. One of the few things that people actually do when they have these debates is actually go and find out what these other people do. So a few years ago, I did actually sit down and read up on a whole load of stuff that building architects do. And it turns out that a metaphor is not an identity. It's not the same as. It turns out that we borrow a lot of good things. We borrow some things incorrectly because we think we know what they do. Yeah, it's that very common belief in a shared experience. Oh, I've seen buildings. I know what architects do. I've walked in buildings. I know what architects do. My wife used to have this. She was a primary school teacher. And she said all the parents thought they knew how to run a school. Why? Because they used to be at school when they were little. You know, that doesn't actually prepare you. Bizarrely enough, you kind of have to go and find out. I remember going into schools to see my wife, and it's just like, wow, this is so different, seeing it from this side. Yeah, it is fundamentally different. So there's a lot of stuff we caricature because we think we know. And then there's a lot of stuff they do, not only that is different, but is the same, or that's a really good idea. Why aren't we doing that? So this is an interesting book, 101 Things I Learned in Architecture School by Matthew Frederick. It's actually about building architecture. It's a lovely book. It's one of these books that makes you look sophisticated, smart, and cultured, and not just some kind of software geek. You know, so buy it, leave it lying around, and people will immediately think higher of you. Christmas is coming, so I wish I were on commission for this. I've recommended it so often, every now and then somebody says, oh yeah, I got that book, it's really great. It's got like a nice picture on one page, and then on the opposite page, it's like a sound bite or a couple of paragraphs. And about half the advice in here applies to any design-based discipline, anything where we are creating something, ultimately for utility and for use. Okay, so about half of that you can take immediately and go, yeah, this is a different perspective, this is useful. In fact, a friend of mine had the interesting situation. He ended up buying 2 copies because he bought it, then his wife stole it off him because she's actually a building architect. He said, what are you doing with this? It's much more use to me, so he had to go and buy a second one. Now, in this one, we got a quote from the Finnish architect, Eliel Saarinen. Always design a thing by considering it in its next larger context. Now, this is important because we're not just simply considering what is the context, we are saying what is the thing around the context. It turns out that context is where most of our meaning comes from. It is also where much of our misunderstanding comes from. It's also surprisingly hard. And I've always been a big fan. One of the first diagramming notations I was taught was Jordan notation. And it had context diagrams. And that was a really big thing in the structured era. And then they kind of got left behind. And it's just like, oh, because those are not object-oriented. Well, they're not anything. They are context diagrams. They show you a picture of the world around your system. They're not anything-oriented. Yeah? But where in the world does this system live? What are the things that we want to do with it? Because it turns out that meaning often arises from action, and meaning often arises from consequence of action. That's how the bell made sense. Okay? But this larger context turns out to be surprisingly hard to deal with. But always design a thing. So let's look at the word design. So design, by default, when we think about it, it is an act of synthesis. Synthesis is putting together. You're creating something. The opposite of synthesis is analysis. You're pulling something apart. And historically, in software development, we've had a very uneasy relationship with these because they have often gone with the idea of, analysis, that is understanding, and then there is building, and these two are separated from each other. Whereas it turns out that they are actually in a slightly more symbiotic relationship. In fact, they're in a cyclic relationship. The best way to look at these is sometimes I try to build something, I take a look back, I understand it. I understand something by looking at it, and then I try and build it, and then there's this rather nice cycle. It is much like a heartbeat. Systole, which is the contraction of the heart, and the muscular diastole. So in other words, there's a heartbeat here. You're supposed to repeat it. But I am also reminded of an interesting thing. I was teaching somebody many years ago. I was a tutor, and she was doing a diploma in computing, and she couldn't understand why she'd got such low marks for an essay of hers. And it was an essay where you were supposed to talk about development process. And when she came to the talk about the waterfall process, she said, the waterfall process, the sequential development process is defined as implementation, followed by analysis, followed by design. I kind of looked at her, and she said, well, yeah, you go ahead, you just throw some code together, you build it, and then you analyze what went wrong, and then you design the right thing. And I said, at one level, you have revealed something truly profound and real. But that is not the answer that was being sought by the instructor. But yes, in one sense, you are right. But it's the notion that there is this kind of rhythm, there is this cycle, there is this breathing. And this is an activity that we find is not unique to something like software. Ernest Hemingway in Movable Feast, lovely book, he talks about the only kind of writing is rewriting. There are other quotes within the writing community, writing is rewriting. This is, and it's a really interesting idea. In my spare time, I write short fiction, and so I'm always interested again in drawing the parallels between that and how I relate to code. And there is this notion of writing is nothing without revision. The idea that we do this with software, that we've actually had to make a case over a period of decades for things like refactoring and revisiting systems, because we learn. When you learn, you revise your understanding. Learning is not merely cumulative, it is also revisionist. You change your understanding. You unify concepts. I found it with my youngest son one day walking back from school. I said, so what did you learn at school today? And he said, he described various subjects. I said, and he likes maths. So I said, so what did you learn in maths? He said, we did ratios. 5 to 1, 2 to 1. So, okay. So, how was that? He said, it's kind of boring. We know this already, Dad. This is percentages and fractions and decimals. It just looks different. In other words, he had reached that point where suddenly it's like, this is not 4 ideas, it's 1. There is only 1 idea here, okay? But that takes time. You can't tell somebody that at the beginning. It's too much for them. But there is this notion that learning is, in this sense, it is not merely you add stuff. We keep talking about adding stuff in software. We don't talk enough about this natural process of revision. It is a natural process. It's not something weird. And so it's kind of interesting. We can look to the world of writing. This is a book on screenplay writing by Robert McKee. It's perhaps a little formulaic, but there's some really interesting insights in here. And one of the insights I love, as it says, if a plot works out exactly as you first planned, you're not working loosely enough to give room to your imagination and instincts. This is a lovely way of looking at it. Okay, I know not everything goes according to plan, but there is this notion, this kind of an alternative way of thinking. What if everything did go to plan? You might feel satisfied at one level, but in another sense, you have been deprived of something. We learnt nothing. It's just like, what happened? I find, and also as an author, one of the most interesting things is when people tell you what they think your story means. And, it's great. And I was given a piece of advice by somebody many years ago. You just nod your head, okay? Because if it means that to them, we're good. But sometimes you do not know the meaning when you wrote it. Honestly, you have ideas, and then perhaps a little bit later, you come back to it and go, there's a thread, there's a concept here. This is this kind of story. I also do spoken word. I read. And sometimes it's only after I've read something that I truly understand what my story is about, and therefore I will emphasize that more strongly in a future revision. This is not different to software. Okay? The meaning, the significance that a software system may have for somebody using it will change the world in which they are in. That's important, okay? So but this idea of working loosely. Now, this is kind of an interesting one because I do quite like words and meaning. It's a mild obsession of mine. I run a page on Facebook called Word Friday, and most Fridays I will put up an unusual definition, a word with an unusual definition, and the rest of the week I just post language and vocabulary-related stuff. But one of the words I featured a few years ago is one used within the writing community. Is Panzer, which has nothing to do with tanks, panthers, or anything, okay? It derives from a very different phrase. It's a writer who writes by the seat of their pants. They have no idea what's going on. This was characterized, I'm afraid I can't attribute the author correctly, but an author was asked by his daughter, "Daddy, why are you typing so fast?" "Because I want to find out what happens." Okay? The act of discovery, this is a really important thing. By doing it, you are learning about it. It is this same kind of heartbeat. What is the story about? Well, let me write it and then I'll tell you. I have some ideas, but as I write them, the ideas start taking on a life of their own. And then I see interactions that I did not see before because I'm now working in detail. Software is always about this. Along with, oh, it's just meaning, or it's just semantics. Another one that people throw around is, oh, that's just details. Honestly, what did you think software was? That really is all software is. Lots of details put together in a way that works. There's no hand-waving when you come to actually do this stuff. Oh, you know what I mean. No, I don't. The compiler, you know what I mean. No, it doesn't. You are committed to detail. Many of the things that people experience that are mischaracterized as coding errors or coding oversights are actually, what they've done is they are trying to push something to a level of precision that only the actual programming is revealed. But sometimes they're asking harder questions of the domain and the world around us, to which we had not even thought to ask. Okay, so it's a process of discovery as well as a process of creation. The contrast here is with a plotter. Panzer doesn't work too well, have an outline. A plotter has a very clear outline. Now, we can present this as a very binary perspective, but I think it's much more of a continuum. Writers live along this range, but I also find that there's something here in sympathy with what we do in software. And there is this very idea that the discovery of meaning is not a simple feed-forward process, that you're going to have to start messing about a bit. You need to work loosely. You need to give rise to your instincts. Now, when we're talking about programming, when we are talking about writing, we're typically talking about language. Now, the problem is that language is a word that is used in many, many different ways. Programming language, highly formal set of rules. It is a language, but it lacks the sloppiness of something like natural language. On the other hand, you get to be completely precise, but you are not coding the machine. This is a beautiful illusion. A lot of people think, oh yeah, this is low level, the whole low level thing, yeah? I'm working in Java, I'm working at a higher level of abstraction than C. Honestly, from a modern processor's point of view, if you're sitting in the processor looking up, you can't tell the difference between C and Java. They are both so far removed from what's actually going on. C cannot talk about what is going on the processor. There was a time that it could, but instruction, pipelining, cache lines, all of these concepts are not available in the language. They cannot be talked about. Okay? It cannot be controlled at that level. So there's a whole load of stuff. From down here, it's just like, yeah, there's some programming stuff going on up there. That's it. You really can't tell the difference between these languages. You're not programming the machine. You have a formal structure that allows you to create a system of meaning. Then we have natural language, which is a bit sloppier, filled with ambiguity. Oh, has a nasty habit of evolving. And sure, a lot of people say, well, my programming language has evolved. I was dealing with somebody who said, oh, I haven't looked at Java since 2010. I said, well, a few things have changed. There's a fundamental shift in the style. I'm dealing with some C++ programmers again. Modern C++ or postmodern C++ is very different to the kind of stuff people were doing in the 1990s. And people might feel frustrated that the fundamentals of their language have shifted so far. But honestly, if you tried understanding children, with my kids, I've got teenage kids, and I'm just very thankful for urbandictionary.com. Okay? You know, it's just like, I have no idea what he just said. You know, I've got it as an app. You know, I don't have a lot of apps installed on my phone, but it's just like, yeah, oh, yeah, I'm down with the kids now. I understand what he's saying. But natural language, this is a problem, because sometimes, I had somebody tweet at me yesterday, I can't remember what I was talking about. Oh, that's just a natural language issue, Kevlin. Just a natural language issue. You have another way of communicating this? We're on Twitter. What else are we going to do? I could throw some emojis at you, but honestly, you know. But then when I start saying language, people go, oh, he's going to get to ubiquitous language. You're right, I'm going to get there. Here it is. Oh, right, gone. No, right, so ubiquity. Do you know one of the hardest things in software? It's naming. Ubiquitous has a very precise meaning. It means it's everywhere. It's omnipresent. Yeah, that kind of runs aground when you talk about abandoned context. Because what you're actually saying is, you know that ubiquitous thing I said? It's not ubiquitous. It's actually context-specific. Whoa, hang on. So the thing you said was context-free is actually context-specific. What do you mean? Why are you using the wrong words? It's in other words, yeah, it turns out this is non-trivial. And I'm not saying you shouldn't try for this, but I just want to point out that there are a number of things, a number of challenges that it's too easy to miss in our goal to create something that is simple. We like simplicity. Sometimes we push it a little too hard and we force simplicity, which is a different thing. So Eric points out, he says, by using the model-based language pervasively and not being satisfied until it flows, I like that. It's a lovely way of putting it. So notice this is about a language of usage. There's a really important quality here. There's a whole bunch of other stuff. He says, we approach a model that is complete and comprehensible. Oh, okay, fine. Complete, comprehensible, simple elements, complex ideas. Okay, all the rest of that sentence is kind of standard computer science stuff. But that flow bit was the surprising bit, and that is the bit that makes the difference. And unfortunately, flow sometimes has a very different opinion about what is complete and comprehensible. There is a natural tension there in how we talk. Domain experts should object to terms or structures that are awkward or inadequate to convey domain understanding. Developers should watch for ambiguity or inconsistency or trip up design. This is a laudable aim. This is a good aim. The problem is we've just put two very different groups on the pedestals, and we're saying domain experts are good at this. Are they? And how good are developers at this? They're okay. And how good are they talking to each other when they discover these things? It turns out that we have some other issues, and there's an expectation, perhaps this is an oversimplification. So I edited this book a few years ago, and there's a nice piece in there by Keith Braithwaite, Read the Humanities. Okay. Obviously, as some of you put pictures up, good for Christmas. Ludwig Wittgenstein makes a very good case that any language we use to speak to one another is not and cannot be a serialization format for getting a thought or idea or a picture out of one person's head and into another's. It may support that role, but honestly, that's not quite how it works. And trust me, I'm going to say, as a writer, this is incredibly difficult, and I'm trying to do this stuff. I go to workshops and trying to improve my writing. And I think I write better now than I did 10 years ago. But ask me again in 10 years, and I'll say, what was I thinking in 2018? I had no idea. This is definitely a journey, not a destination, because this is non-trivial. To say what you mean and to convey that, but also to have somebody else interpret what you mean is difficult. Wittgenstein also shows that our ability to understand one another at all does not arise from shared definitions. Now, this is really important because often we're saying, oh, we're looking for a shared definition. I'm not saying a shared definition has no value, but sometimes we say it has all the value. We put too much hope into it. It arises from a shared experience, from a form of life. In other words, it is a process rather than an artifact. You have to kind of experience it. You have to be there. You cannot merely observe the context. You have to be within the context. This may be one of the reasons why programmers who are steeped in their problem domain tend to do better than those who stand apart from it. So, yeah, mind the gap between these two things. There's another one which I quite like in here from Nate Jackson. And the title tells you everything you need to know. Your customers do not mean what they say. Here are your domain experts. Let's listen to them. I've never met a customer yet that wasn't all too happy to tell me what they wanted, usually in great detail. The problem is that customers don't always tell you the whole truth. They generally don't lie, but that does occur. First thing to notice, by the way, is there's a little linguistic thing that we've just done here without really realizing it. Customers. Customer. A customer. What is a customer? That's kind of an interesting concept. A customer. Now, sometimes when we talk about a customer, it's a unified entity. It's an anthropomorphic unified entity. Feel free to drop that phrase in a conversation. What do I mean by that? It's a unified entity. What is a customer? In most cases, we're not talking about one person. When I walk into a shop and I buy something, that's me being a customer in the classic sense of the word, customer and shop. But when we are talking about business, we are using ideas like customer and business. You ever heard people talk about the phrase, the business? Have you ever met the business? Male, female, indeterminate, tall, short, eye color? It turns out the business is an artificial construct. As humans, we're great at this. We have great imagination. But we also simplify the world. And it turns out we're good at dealing with other people. Well, sometimes some are better than others, but nonetheless, we use that and we project this concept of an individual onto more complex organizations. We anthropomorphize them, we unify them, treat them as a single entity, and then make them human. You find this when people are talking about the markets, the financial markets. Oh, the market's in a bit of a mood today. What? How does that even work? I mean, moods, that's emotion, that's based on the chemistry of my body. I mean, sure, I've heard things about the kind of drugs that people in financial trading take. It's normally cocaine, but that's probably not what we're talking about. There's a notion here that we perhaps have oversimplified, the customer. So therefore, people are not necessarily intentionally lying. What happens is that when you meet a member of an organization, they have a particular point of view. And if you meet somebody else who also represents that organization, they have a different point of view. And they will tell you different versions of the truth, depending on departments and history and their relationships within the organization. It turns out that they are human, but the organization is not. They clearly use their terms in their contexts. Just one, hopefully we're comfortable with. Yeah, then it gets interesting. They don't tell you everything. They leave out stuff, and that's the hardest thing to see, the thing that is not there. When somebody uses a word, you go, what's that mean? When they use an abbreviation, and sometimes you can do things like a significance check. One of the things I find very useful when doing code walkthroughs or when listening to a meeting about business is what words keep coming up? And are those words present in other documentation, in the code, in the tests? Because these words are clearly quite important. And if they're not, then it's, there's a question there. Why are they not there? The thing that is hard to see is the thing that is not there. The omission. Oh, the accidental abstraction. Damn, this is hard stuff. Because it involves people. They make assumptions. What is an assumption? When do you know you have an assumption? Well, this is one of those rather curious things. You know when you have an assumption when it is contradicted. Yeah? Oh, I didn't realize that. I had assumed that. At that moment, you have an assumption. Prior to that, you did not know you had the assumption. At that moment, okay, I had assumed that. It was a moment of discovery. It was a moment of interaction, and things did not quite work out the way you expected. It was a mismatch between your model and something in the world. Oh, that's an assumption. So therefore, whenever, I remember seeing a project document many years ago, it said, project assumptions. I love that. I mean, if you know how to do that, that's fantastic. But honestly, the best you're ever going to manage is known assumptions so far. Brackets, to be continued. Yeah? This is compounded by the fact that many customers don't actually know what they want in the first place. Now, whilst this is true, we have a nasty habit, and this is something, and I can think way back in my career, of this frustration, and it often occurs, you still see it in online conversations where people will say, oh, yeah, the problem is the customers don't know what they want. I have some very bad news for you, or good news, depending on how you look at it. This is compounded by the fact that many humans don't actually know what they want in the first place. Don't pick on the customers. It turns out we're all in the same boat. Yeah? Honestly, we have no idea. Yeah? What do you want out of life? What's your 5-year plan? I don't know. Some people do have a 5-year plan. But a friend of mine who worked as an estate agent for a while, he revealed very quickly that humans, you'd think, okay, here's a couple, they want to buy a house. Surely they've had the conversation and figured out what they want to buy. He says, honestly, no. The number of people who came in and actually agreed with one another or had the discussion about stuff. Oh, yeah, when I said I wanted a front garden, I meant I didn't want a front garden. Or, on-street, off-street parking was important, but actually for this area, no, it isn't. It turns out that it's a surprisingly rich and complex thing. People really don't say what they mean. So, I'll stick with the writing a bit. Neil Gaiman, one of my favorite authors, he talks about offering advice to people who deal in creativity. You have to finish things. That's what you learn from. You learn by finishing things. It's at that moment that you suddenly look back. This is why we prefer an incremental form of development. Honestly, for me, this is why I prefer writing short stories, because I finish more of them. I learn. Once you have finished it and sent it off, you suddenly have a slightly more objective sense than you may have had before. It is not simply like writing a chapter. You finish a chapter, what have you learned? That you've got another chapter to do. So I know lots of authors who are struggling still to write their first novel. And it's my ambition to not write a novel. I have to say I'm being more successful with my ambition than theirs. But the point is, I have learned a great deal by finishing things and experimenting with variations. At that point, this is complete. Is it any good? Well, interesting, I've learned this, I've learned that. So there's this idea of reaching points of completion. This assists in our learning. We are able to tie off our knowledge and say, what changed? What still is a question here? What keeps moving? So this is obviously not new advice. I mentioned engineering earlier on. This year I've been talking a lot about what happened 50 years ago. In fact, 50 years ago last week. The NATO Software Engineering Conference in Garmisch was a landmark conference that is widely misunderstood, but has some fascinating content, and it presents a group of people who have a very different view than we thought they did. Everybody thinks, everybody said that the software engineering is like bridge building, or it's all about the software crisis. Honestly, that doesn't really happen much. The software crisis is mentioned in about 2 paragraphs. But it turns out that there was a rich body of thinking, and we've been doing these people a disservice. There's like radical ideas like the design process is an iterative one. Yeah, there you go, 1968. Okay? Something happened in the 1970s. I don't know. Maybe it was disco, maybe it was flared trousers. I'm not sure. Something happened. But clearly, we were on the right road. There's this idea of there is a learning cycle, the idea that you're going to get it right first time. If you do, that's great, you're lucky. The problem is we don't yet know what we mean by right. Also popular in the 60s, and this was referred to in a number of cases in the software engineering document, notes on the synthesis of form. Christopher Alexander, published in 1964. He is best known for his work on patterns. Basically, he invented the idea of patterns, but this was his precursor work. And here he was interested not just in buildings, but in how things are created. What is the process by which things are created? Concepts are created. How does this happen? And he makes a couple of observations, and there are 2 ways. There's one obvious way of reading it. We may therefore picture the process of form-making as the action of a series of subsystems, all interlinked yet sufficiently free of one another to adjust independently in a feasible amount of time. It works because the cycles of correction and recorrection which occur during adaptation are restricted to one subsystem at a time. This sounds like a very good architectural idea. This was inspired modularity. There was a lot of talk about this is how we should think about it. Notice this idea of recorrection, and we have a natural boundary within which to do that. And yet our systems can be kind of loose with respect to one another, tight within one respect, but loose within another. We seem to be bounding something here. Yes, because he's not talking about any specific kind of subsystem. He's also referring to any kind of subsystem. It could be a software system. It could be a system of meaning. Things change. Now, the problem, however, is finding the right boundary. Because sometimes things change. We establish them. We have this idea that once I have made a decision, then just as in the real world, we have this assumption that if I leave something, put it down, walk away, go back, pick it up, it's still there. This is our assumption about the physical world. It's a little bit like programming a single-threaded program. Yeah? And then you get married or you have kids, and suddenly you discover that your basic assumptions have been utterly undermined. Yeah, I'm sure I put it there. Well, yes, you did, but that's the past, dude. You know. And this is the problem. The way that we think about our decisions and we think about our work and we think about our code, is that decision which was made, was made. You know, it's like a sediment. It's like a geological sediment. And the idea is, you dig, well, often there is the act of software archaeology, and you dig down through it, and you go, oh, yep, this is where the dinosaurs died. Yeah, and it's just like, and beyond that in the code base, there's other stuff, and we're not quite sure what it was, but it still seems to be working. And there is this notion of we assume it just gets layered up like that. But that's not how it works. Things change beneath your feet. Kind of here's a good one about assumptions. First Roman programmer. Month 7, 8, 9, 10 don't have names. What should we call them? Second Roman programmer. Just number them. Whoa, wait a minute. Isn't that bad practice to hard code numbers? It's fine. They'll never change. Fine. September, October, November, December it is then. If you've ever wondered about the names of the months, pause a moment. Okay? Yeah, it's an off by 2 error. Things got shifted around a bit, okay? But we still kept the names. Yeah, so I live in Bristol. It's across the bridge from Wales. The nearest town in Wales, nearest city is Newport. It hasn't been new for centuries. And actually it's not an active port anymore. But, calling it the first major city over the bridge is probably not, they're not going to go for that renaming. Yeah? So there is this notion that sometimes what you thought was a fixed point is no longer a fixed point. The language moves. And I can see that even just little things, a system that I worked on a logistics company a few years ago, the name of the system had a particular spelling. And we don't spell it that way anymore in British English. Yeah? Language moves. The spelling has changed. But because that was how it was spelt in the late 80s, that's how it was spelt in the early 21st century. And it probably is still spelt like that. Yeah? So this idea of meaning and the symbols and the vocabulary that we use, the ideas, the misunderstandings we can have, we spent a bit of time in pattern-oriented software architecture. Another use of the word language, pattern language, but I'm not going to explore that here. In this book, we really explored a lot of stuff about pattern theory and ideas that don't generally get discussed elsewhere. Sometimes people say, hey, should I buy this book if I want to get into patterns? Disappointingly, no. This is the book that you want to buy after the other books that you've bought. And honestly, if you're still interested, you've survived enough to, this should shut you up, okay? In other words, it's the last book you ever want to buy on patterns, yeah? However, we made some observations about semiotics, which is about the meaning of signs and association with symbols. In its earliest form, and this was actually to do with patterns, but I just thought it's a broader point here. In its earliest form, semiotics, semiology, in other words, there's a notion of meaning here, defines a sign as a two-part whole, a dyad, comprising a signifier and signified. Okay, the signifier is the expression of the sign. The signified is the corresponding mental concept. Oh, okay. So how can we misunderstand one another? Let's talk about the natural language, the ubiquitous language. How ubiquitous is it? So I had a girlfriend a long time ago. I'm originally from London, and she was from Yorkshire. It turns out that English is a little bit different. And and this is in the era before, mobile phones and useful stuff like that. So one day she said, oh, do you want to come around on Sunday for dinner? I'm going to have some friends around. It'd be really cool if you met them. I knew some of her friends, but not all of her. I said, yeah, fine, great. So I kind of turned up at 6 o'clock, thinking I was early. If you're in the Netherlands, then you're late. If you're in Norway, dude, that was so many hours ago we had dinner. But she was in a really foul mood, and I couldn't work out why. And then it's just, eventually, as we're starting to eat, it's just like, aren't your friends arriving? No, they came 5 hours ago and left without you. It's just like, oh, okay, yeah. It wasn't the end of our relationship, but it was definitely on the downward slide. And that's just a North-South Divide thing. We have just used the same signifier, and we've ended up with actually talking at cross purposes. Of course, this never happens in technical domains. Oh, no, never. And there's a lot of different bits and pieces about these things. Yeah? 2:30. Yeah. Now, based on the fact that we're in Berlin, a lot of you sit and go, 2:30. Yeah, sure. And you go, fine. 1:30. It's just like, no, I'm from Britain. You're off by 1. It's 1:30, not half before. But also notice an assumption here, another assumption, which is, I haven't said that, or that. Why? Because your current context is the afternoon. Why would, if I said either interpretation, 2:30, 2:30, you wouldn't immediately be thinking, oh, you must be talking about just after midnight. No, because your context, it turns out that the fuller semiotics is guided by the context. It's not just the sign and the signifier. It's, and where did this occur? Where did this occur? Well, it occurred in the afternoon, so naturally we made an assumption that we were at this time frame. And by the way, if you ever try and use, 2:30 in North America, everybody thinks it's 1. Yeah, they just think it's a piece of arithmetic, yeah? So the point here is you've got to watch out for this stuff. It gets us. But we do this as well. We think, oh, well, no, we're technical. We're using the right words at the right time to have the right suggestion. Do we have a ubiquitous language within our own development culture? I'm going to say no. We're talking about velocity. Development velocity? Yeah, people are very keen on development velocity. But when you look very closely, it turns out they're not talking about velocity. They're talking about speed. These are two different concepts. Now, I'm afraid I have a degree in physics in my background, and I cannot shake this, because to me, this meaning is important. Velocity has direction. Honestly, the way that most people develop, I don't think they Damn, we're going fast. Yeah, but you're going the wrong way. Yeah, but we're going fast. Honestly, if you walk the other way, that's one of the things I love about coming to Germany is this whole notion, and there's clearly a relationship between these two, but it turns out that that is a simplification. What I've just done is I have taken a magnitude with direction, and I've just said, don't worry about the direction. It's just the magnitude that matters. I have simplified it, but at the same time, it's like, we might have lost some really important data there. And one of the things I love about coming to Germany is the Autobahn. It's just like, yes, there is no speed limit except when there's traffic. So, you're heading into Frankfurt on a Sunday night along with the rest of Germany. It's just like, oh, this is where all the bankers come in on a Sunday night. At that point, you suddenly discover there is a speed limit, and it's context defined. It's not formal. But there are other things, and I discovered one day I was doing. I love it. There you are shooting along. Much faster speed, 150 kilometers per hour, 160 kilometers per hour. You think, this is great, and then something black shoots past you. It's so fast you can't tell if it was a BMW, an Audi, or a Mercedes-Benz, but it was black and it was fast. But nonetheless, you go back to being satisfied with your own current speed. And you make a mistake if you are satisfied with your own velocity, because I have discovered one day, heading off at great speed, the sun is in the wrong place. I am heading in the wrong direction. I would have been better off walking. Okay? But then we say, what about notation? Oh, surely these people all use the same notation. Well, in physics, we'd see that. Oh, it also is known as this. Oh, great, we've got two notations. This is one field. Then we simplify it further, and we say, no, don't worry, it's just distance with respect to time. Notice we've gone through 2 steps of simplification. We lost the direction, and then we just said, oh, don't worry about the changes. Just imagine it's all kind of like, straight. In other words, this is where we force simplicity onto our concepts as portrayed by our vocabulary, as communicated by our vocabulary. And then we have the idea of defining by omission. Okay? Some things are defined by their absence. Okay? Again, these can be surprisingly hard to tell. And then somebody comes along and says, oh, no, a sentence must have a verb. And I say, well, where did you learn that? Well, my teacher, when I was 8, told me that. It's just like, yeah, okay. But your teacher's unfortunately going to lose against the linguists. They have a deeper understanding of this. Your teacher was probably telling you that to encourage you to remember a verb. So your teacher wasn't necessarily lying, but they were giving you a truth that helped you at that point. Just as sometimes we do when we introduce other people to our domains, our technical domains, but also, guess what? The same is happening with you when you are introduced to something else. People are missing things out, and then they're oversimplifying things, and you think you've understood it, and actually they just gave you the really simple version. And if we're going to talk about omission, sometimes we find it very difficult to define certain things. This screen is blank. But the moment I put a sign on it, it's no longer blank. I'm trying to label it helpfully, but I'm afraid that's not the way it works. And then somebody says, yeah, but where did the word blank come from, Kevlin? Blank came from the French, blanc, which means white. A blank screen is black. Oh, okay. So we've ended up with contradictory meanings. That never happens at all in the real world, in any domain, ever. Then we also have a priming effect. Rot. Yeah? That works with this audience because everyone's going, oh, yeah, yeah. And I've used the color red to prime you. I've given you extra contextual stuff. But if you say that, you say rot, and if I'm hearing it in slightly flatter English, I hear wrote. It's an act of writing. I also hear rote, which is an act of learning by repetition. And I think, oh, repetition, that's a thing that, we don't value. Don't repeat yourself. Dry principle. But then that also takes me back to the English interpretation. Same signifier. Dry, rot. Completely different concept. It's about decay. Now here we have, it's very easy, and normally you don't end up with these conflicts, but I'm laying out the simple ones. Most of these are far more subtle when we're speaking about domain. There's all these little flows of context that you're not aware of. It gets more interesting when people genuinely do mix disciplines. Interdisciplinary subjects have mixed vocabularies. Trying to find any kind of meaningful boundary, it turns out that the creation of bounded context is not an act of discovery. Sometimes what you're doing is you're creating. There's a mix of discovery and creation. You're actually synthesizing a language. But the point is you need to make sure that everybody knows your decisions. So when we do that, so far I've been using words, but honestly, colors also have meaning. Red, what does it mean? Red is the color of danger. It's also the color of celebration if you go to the Far East. Okay? There's all kinds of things that it signifies. Blood, there's all kinds of stuff that goes on. Danger, do not cross the red man. Yeah, nice bit of graffiti. But the notion there is red means stop. And this is how kids learn it. Red means stop, green means go. It also turns out that sometimes you can change the meaning of something just through a small modification. And we're not always very good at detecting the sense. What happens is when somebody says something, you think, oh, this is a new idea. They were talking about it. The domain expert did something on the whiteboard, and you walk away with an understanding because they're using some of the same words they used earlier. But no, they actually mean something slightly different because they just modified them in some slightly different way, or they borrowed vocabulary from a different domain. We hit red, then we play with green. Now, if I put red and green together, you think traffic lights or test-first programming. In other words, we're creating a system of vocabulary. But then we think it's ubiquitous and we're sharing this. Are we having a shared experience? No. I'm red-green colorblind, and my wife and I went to this art installation at the Botanical Gardens in Bristol this summer. And we come round and she says, can you tell what that says? Tell what says. But I'm a technologist. I'm not stupid. I got out my phone, took a photograph, and it's just like, ha-ha! Yes, the power of technology has allowed me to see that it says, is this red? No, it's grey. But the point there is that you've assumed something about the listener. You've assumed something about the reader. You've assumed that the other person, and this is clearly a physical thing, but the point there is that we're talking about your wiring. We're talking about your knowledge set. And sometimes you will not see something. You are not allowed to see it by everything that you've already got. You have to do hacks like this. And this is why we have various techniques to slow us down. Honestly, my wife could tell that in an instant. I had to go via a hack. So we use techniques to try and understand what is the shape of our software system and the domain that we're dealing with. We have all of these techniques, and I think we like to think, oh, they're helping us communicate. The whole point is they're trying to slow you down, just make you nudge and catch your own blind spots. And then there are things that not everybody can see. Bizarrely enough, not only red-green colorblind, but I'm synesthetic. Grapheme number. In other words, I see an association between colors and numbers. And this is a fairly standard test. As far as I'm concerned, this is really obvious. I can see the twos leaping out. Although in this test, they did use the wrong colors. This is the problem with synesthesia. Your synesthesia and my synesthesia are different. Yeah, for me, 2 is red and 5 is, 2 is green and 5 is red. Okay, so 6, just for fun, yeah. But there is this notion here of I'm now able to see these various things. I make connections that other people don't, okay? By a fascinating coincidence, KanDDDinsky was also synesthetic, which is one of the reasons that informs his art. He had different associations in terms of his cross-sensory wiring. And then we mess people up. We say, hey, look, that's green. Now, what color is that? Yeah, this is known as the Stroop effect. It's actually on the front of the original Scrum book. The Stroop effect is an interference effect. It occurs when you get two domains colliding. Okay, you have two sources of knowledge. You have two sources of meaning. I have a color that gives us one meaning, then I have a word. These collide. You've seen this in code bases. Okay, first time I ever experienced it was the concept of network. What is a network? It turns out there's a lot of things. It's a graph structure. It refers to TCP/IP, and in the context that we were in, it refers to an electricity network that distributes electricity from power stations. The word network occurs. In most of these cases, these are very clearly bounded contexts. So I can actually say, that's a data structure thing, that's a network thing, and that is a domain thing. But sadly, it's not always so easy. But also, you will find yourself talking at cross purposes. You have to be aware of the interference effect. We have words like value. Great word. We keep talking about it. Yeah, Scrum talks about it a lot. Oh yeah, you got to do stuff by value. You got to do value. Oh, okay. Well, people clarify it a bit. Business value. Okay, and they say things like we're going to prioritize by business value. Okay, that sounds brilliant. There's only one thing: you can't do it. It's actually not possible to prioritize features by business value. Or rather, it is, but you need a time machine to do it. The best you can ever do is prioritize by estimated business value. Because honestly, if you know the business value, you are some kind of god. You can estimate it. An estimate is a probability. It is a range. I can say, we think this is going to be this, but you are not guaranteed that. Okay? So when people are prioritizing by business value, they are prioritizing by an estimate. That extra word changes the game completely. Oh, but it's just one word, Kevlin. Yeah, turns out it's a very important word because it gives us a little bit of caution, a little bit of humility. It makes us ask questions. Yeah, so well, how do we know? Well, hang on, slow down a bit, and do we reevaluate afterwards? If you don't use that word, you don't reevaluate. Yeah? So there's this notion of these words matter. And we also drive too hard in terms of it devalues our software development. This is one of my favorite cartoons. Yes, the planet got destroyed, but for a beautiful moment in time, we created a lot of value for shareholders. Honestly, I think there's got to be more to software than this. So when we talk about value, we also need to be careful of other things. So I said I'd refer to the Meyer Lehman paper again. And Laws of Software Evolution, some really good stuff. So back in 1980, he came up with this idea, this classification, S programs, P programs, and E programs. This is quite a useful way to understand the scope and consequence of the thing that you are trying to design, as well as trying to find the context consequences. An S program whose function is formally defined by and derivable from a specification. Sorting algorithms, data structures. This is the kind of the basic stuff. We're all good with that. Graphics programs, actually even operating systems. We can formally define them and you can derive something from it. I'm not going to say these are relatively easy, but if we can only make all of our systems, if we can make our complex systems out of these are testable. We can talk about them reasonably. Then we hit P programs. They're a little bit harder. P is for a procedure in the sense of I have a procedure to determine acceptability of the solution. Okay? But I cannot derive the program from first principles. If I can give you the rules of chess, but it turns out that doesn't help you actually create chess program. I can give you a climate simulation, but it's all floating point numbers. It's not how the real world works. It's all approximate cells. Okay, the world does not work in cells. Well, apart from mobile phones, but it does not. The weather does not work in cells. It's a much more. It's discrete, but at a very, very fine level. So there is this notion of I have an acceptability criteria for this, but that's not the one I'm interested in. This is the one I'm interested in. E programs, because this is a lot of what we create. Programs that mechanize a human or societal activity. The program has become a part of the world it models, and it is embedded within it, and therefore. The software is part of the world. And therefore, the world will change the software, and the software will change the world. In other words, it changes its own inputs. If you think about social media, this is a kind of a key thing. Now, what does this mean? What this means is that when I do this, remember I said earlier, meaning can be derived from action and consequence. What do I want to do with something? Let's understand the meaning of what happened here. This is 2011, and this is an automated. There's an automated system here that Well, okay, the making of a fly, the genetics of animal design. Now, I'm going to say that sounds like a very good book if you're into genetics. You can buy it used for $35. New from 1.7 million? Whoa, that's quite an escalation. I mean, even in yen, that's quite expensive, okay? This is major. Anyway, this guy went and observed the relationship. What was actually happening, because notice there's another one down there, just over 2 million. What was actually happening is the software had been effectively designed as an S system. In other words, what we do, how do we run our business? Well, what we do is we look at the ratios. This is the thing, okay? The ratios. What you've got is somebody has the book. Their goal is to undercut the lowest other vendor in the market. That is our business model. We have a rule for it, okay? That is our rule. We've got a little context that is our business, and this is our book. Sadly, there is somebody else out there who does not have the book, and they have a slightly different model. Their model is, we'll mark up slightly, which will allow us to buy the book from somebody else and then sell it at a markup. Individually, both of these is correct. Their understanding is beautiful. This is the next larger context I was talking about earlier on. And what happens when we put these two systems together? Actually, it takes it all the way up to nearly 25 million before somebody realized there might be an issue here.
The $3.99 shipping's ridiculous.
Yeah, you kind of wanted to say, look, honestly, yeah, you could throw that one in for free. Yeah. But this is the thing. When we love throwing the word context, but yeah, those boundaries are really hard to define. What is the boundary of an S system? It's really simple. What is the boundary of an E system? It's a bit bigger. It's got a lot more of the world in it. And the world is a very surprising place. The meaning in other words, the meaning and action and consequences, these are all related. Now, you might say, oh, that loophole was cleared years ago. Yeah, except for the fact that although the British are currently undergoing a large social experiment, which I have to say is not going very well at all. It's particularly poorly informed, and I hope everybody's going to learn something from it. But a couple of years ago, now the pound is not doing very well, but look at that drop, bang. That's a really short frame of time. Human traders can't do that. Human traders can't respond that fast. Even with amphetamines, they can't respond that fast. This is the work of machines, written to exactly the same kind of careful, correct, localized, bounded knowledge that we saw with the Amazon example. Meaning is consequence as well. So when we talk about full stack development, you kind of got to go out a bit bigger. So kind of with that in mind, there is a notion here that I want to close with some of the terminology that we use is still very programmer-oriented. This is a rather nice book. If you're into this idea of how do I understand domains and reasoning, this is a book, a follow-on book. This is published in '95. Michael Jackson, yeah, he didn't just do thriller. Did some really interesting thoughts in here. It's a very dull title, but it's an interesting book because it orders alphabetically a series of thoughts and ideas about software development, but also our misunderstandings and how we reach these misunderstandings, and frames for understanding different domains. And he talks about domain relationships and subdomains, and it introduces an idea of problem frames, which he elaborated further in 2003. And I find that even when we start talking domain, we are still moving sometimes too fast. If you remember the systole, diastole, the heartbeat, it's okay, you can go in and out, but sometimes you really need to go and ask, honestly, what problem are we trying to solve? And sometimes that pause, you say, we are in a hurry, yeah, sure we want to create stuff, but sometimes you need to call people up and say, actually, what does that mean? What does that mean for the business? What does that mean in terms of vocabulary? What does that mean in terms of a structure of a domain? What does that mean for the development? So, actually, I'm not going to skip the value object thing. So, when somebody says, we don't want to spend time on that, it's just semantics. They'll say it's just meaning. That's the beginning of the conversation. Thank you very much.